Hi, welcome back to Mooson Chemistry. This is Chemical Equilibrium and Rice/Ice Problems, Lesson 5. If the Kp for the following equation is 2.4 times 10 to the negative 9, and the initial concentration of CO2 is 2 atmospheres, what are the partial pressures of the substance at equilibrium? Okay, first of all, let's write our equation out here. So we got C, and that's a solid. We have CO2, and that's a gas. And we have 2CO, and that's also a gas. Guess what? We get to cancel this one out because of the solid. We're not breaking the solid apart. All right, so our initial volume of our CO2 is 2 atm, and our initial volume of our CO is 0. Pretty cool, atm. Let's just go ahead and put the atm in there. And now the change. Now the change is we lose one of these. It's because there's not a 2 in front of that CO2 there, right? So it's just minus x. And then this 2 right here means that we're going to gain plus 2x. So this is going to be 2 minus x. This is going to be 2x. Pretty darn snarly. That's what I have to say. All right, so now do the rest of it. So what we're going to do is we're going to take and know that Kp, guys, Kp is equal to products over reactants. I'm just going to call it P over R, keep it short. And so you go Kp equals our pressure of our CO squared. Why is it squared? Because of that 2 again. Okay, divided by our pressure of our CO2. So this is going to, and we have our Kp value, so this is going to give me 2.4 times 10 to the negative 9 equals, it looks like it's going to be, yes, it's going to be 2x squared over our let's see here, 2 minus x. All right, so now we're going to take that up and we're going to continue on with our math, and we're going to get we're going to throw this x out. We can throw this x out, and the reason why you can throw this x out right here, now let me show you why. If K, right, if K is equal or is less than 1.0 times 10 to the negative 3, you can throw it out. You can just remove the x, just get rid of the x. So what this gives me now is 2.4 times 10 to the negative 9 over 4x squared over 2. So we go 4x squared equals 2.4 times 10 to the negative 9 times 2. Okay, and when we do the math there, okay, so we're going to do the math, and we're going to get x to equal 3.5 times 10 to the negative 5th. So I'm going to take that and place that back into this x and this x to get each concentration. So the concentration for the CO2 is going to equal 2 minus 3.5 times 10 to the negative 5th. And the other one that's going to be the 2CO is going to be 2 times 3.5 times 10 to the negative 5th. Okay, so our first answer is going to give us, of course, 1.999 ATMs. Pretty darn snarly, huh? And our second value is going to give us 7.0 times 10 to the negative fifth ATMs, or 0.12345 ATMs. Pretty darn snarly. Well, listen, you be cool, you be snarly, I will see you back here at Moosine Chemistry!